Welcome back. This is Mr. Hassan's Maths channel. I'm answering question number 8 now from the October-November 2023 Cambridge 9709 syllabus, paper 1, pure mathematics. This is variant 3, and this question here is about trig graphs, transformations of graphs. Now the diagram shows part of the graph y equals sine of, in brackets, a times brackets x plus b, where a and b are positive constants. State the value of a and one possible value of b. Okay, so now with these questions and with these videos, I like to try to help students who maybe don't have a background in the topic, which is very strong, and so therefore I'm going to take a bit longer than I normally, of course, would do to actually answer the question, because I want to explain the concepts behind it. All right, so those of you who are here as just looking for the mark scheme and the answers, whatever, then just read the mark scheme. All right, I'm not here to just read out or to be a talking mark scheme. I'm here to explain the concepts for my students primarily who might need that explanation. So you need to bear with me if you're just looking for the answer. Now, the diagram shows, as I said, this part of this graph. Now, I can deal with this question in two ways. I can deal with this question by using an algebraic method, which I'm going to show you after I've first shown you the method that involves transformations, because we need to understand the transformations method for sure, especially for part B of this question. All right, it becomes very difficult to do a question like this, like part B, without understanding transformations. You need to understand transformations. Now, in this case, what I'm going to do is I'm going to first draw the y equals sine x graph between 0 and 360 as it normally looks, without any type of transformation at all. Y equals sine x. Okay, and we should all know how that looks. We should know that it starts from 0, 0. It reaches a maximum of 1 at 90 degrees, goes down back to 0 at 180 degrees, then back down to minus 1 at 270, and then at 360 goes back to 0 again. So it looks something like that. That's 0. So in terms of pi, that's pi over 2. That's pi. That's 3 pi over 2. And that's 2 pi. So that's how the sine curve looks without any type of transformation at all. That's y equals sine of x. Now the transformation that's taken place has caused it to look something like this. Of course, this would continue on as well on this side. Like the pattern will say it would continue. Now, so we can see here, first of all, that would be 1, that would be minus 1. That if we look at this particular graph, or this, compare sine x to sine of a times x plus b, then we can see that the part that is like outside the function has not changed. It's like you multiplying there's nothing multiplying the sine of x, the whole thing, and there's nothing added to the whole thing. All the changes that have taken place are inside the function. They're within the function, inside the bracket. There's no changes outside. Okay, so what is affected by changes on the outside are the y coordinates. Okay, so just a little recap. If you have f of x plus, for example, p, that is a translation of p units, okay, in the vertical direction. The same sign as this, that will be the same. And if you have, for example, p times f of x, that will be a vertical stretch of factor 2, or factor p, sorry, whatever that is. So if it's 2 times f of x, it will stretch vertically. Now here, none of that has taken place. There's no vertical stretch. There's no, translation, okay, because the outside of the function is the same. It's like 1 times sine of something plus 0. Nothing's been added to it. Nothing's been multiplied by it in terms of the outside the function. Okay, the changes that have taken place are all inside the bracket, all inside the function. And that's where the x coordinates are affected. Okay, the x coordinates are affected. Okay, for the x coordinates, if you have, for example, f of x plus a, that causes a translation of in the x direction of the opposite of whatever that number is. So if it's plus a, it goes a to the left. If it's minus a, we go a to the right. Okay, so whatever number that is, it translates horizontally in the x direction by that number, which is always the opposite sign. And you also have a stretch. If you have f of, for example, let me call this q, so that it's not the same as the letters that we've been given. F of qx, well, that's a horizontal stretch in the x direction. All the x coordinates are multiplied by not q, but the reciprocal of q, 1 over q. Okay, so here the y coordinates are multiplied by p. Here the y coordinates, you add p to them. Here the x coordinates, you take away q from them. Here the x coordinates, you multiply them by the reciprocal of q. All right, so that's the basics of transformations. Okay, outside and inside the function. Outside, y coordinates are affected. Inside, x coordinates are affected. Here, the only changes taking place are inside the function, inside the bracket. So we can say that only the x coordinates will be affected. Now, when you're dealing with a combination of transformations like we have here, if it's dealing with the y coordinates, like for example, if I had, something like p times f of x plus q, then you go in order of bidmass. You go in order of bidmass. You deal with, the multiplication before the addition. Brackets, indices, division, multiplication. So the multiplication comes before the addition. So you deal with this stretch first and then that translation. Okay, but if it's inside the function, you do the opposite. You do bidmass, but you go backwards. So in this case, what we have here, so for example, you deal with, if you had something like, for example, let's say f of px plus q like this, you would first deal with the translation and then you'll deal with the multiplication. Okay, you deal with this first and then you'll deal with that. Okay, so that's the difference between outside the function and inside the function. Now, in this particular case, what we have is we have y equals the sine of, and then you got a, then bracket x plus b. So everything is inside the function that's been affected, only inside the function. But you have here a multiplication and a bracket. Now, if we're going to be inside the function, we have to do the opposite of bidmass. Okay, we're going to go in the opposite direction of bidmass. So I have to deal with the multiplication first and then with the bracket. So the first comes the multiplication because I'm inside the function. Okay, so I have to deal with the a. So I have to deal with, for example, f of ax first. Okay, which is a horizontal stretch. A horizontal stretch of factor 1 over a. Okay, a horizontal stretch of 1 over a. So now let's see how has this been stretched horizontally. Well, what we can see here is, between this point and that point would represent the same kind of situation as what's happening here, between these 2 points here, between 0 and pi. They kind of correspond to each other, what's happening. It's like from 0 to 0. Okay, so you can see this has been stretched. This from minus pi over 3 to 5 pi over 3. Okay, that distance is 2 pi. From here to here, the distance is pi. So it's been stretched horizontally by a factor of 2. Okay, by a factor of 2. Okay, so what we can say here is a has to be equal to a half because it's been stretched by a factor of 1 over a, the reciprocal of a, right? So a has to be a half because the stretch factor is 2. The stretch factor is 2, so a has to be a half. Okay, so that's what we deal with first. And then the second thing we have to deal with is then what's inside the bracket. And what's inside that bracket is an addition. You have the plus b. Okay, so we're going to deal with now the x plus b part. Now, as I said, that's going to be a translation of minus b0. Okay, so let's look at a point, for example, if we compare where this was where it started. Okay, it would have started here. Okay, so, and then what's happened is moved to the left by minus pi over 3. So we can say that minus b is going to be the same as minus pi over 3. Okay, minus b is going to be the same as minus pi over 3. So therefore b is equal to pi over 3. Okay, so we got b is pi over 3 and we have a as a half. And those are the two answers to the question, because it's a translation of minus pi over 3, which has to take the opposite sign inside the bracket. Okay, so this is actually the sign of a half times x plus pi over 3. So the first thing we deal with is the multiplication, because we do the opposite BIDMAS. So the first thing that happens is it gets stretched by a factor of 2. So this basically goes from there to there. And then it shifted pi over 3 to the left. So it just goes back pi over 3 to the left. So then it looks exactly like this. Okay, so that's how we can try to understand what's happening here. So the original function would have looked something like this. If I just draw it here, whoops, make it a bit better than that. The original function would have looked something like this. So what's happened? It's been stretched by a factor of 2 first. So it became like this. And then it was shifted to the left pi over 3. So it ended up looking like that. Okay, so that's exactly what's happened here. Okay, so I hope that was clear. All right, for part A. I'm also going to show you how to do the same question using an algebraic method. So I'm going to do the same question using an algebraic method. So I've got a copy of the same question on the next page. So I'll show you how to do this algebraically as well. Now, algebraically, what we could do here is we could say, okay, let's take y equals the sine of ax plus b. And let's choose a pair of coordinates that are easy to use from our graph. So for example, I can choose this point. That's a nice easy one. That's 0 and 0.5. So if I use this point, 0 and 0.5, let me take it down here and do it properly in the space that I have. If I take this point, I can say, okay, that's x equals 0, y equals 0.5. So I can say 0.5 is equal to the sine of a times, and x is 0, so it's a times b. Okay, so we end up with the sine of ab equals 0.5. So we can say that if I find the inverse sine of 0.5, the first solution we're going to get in this region is going to be pi over 2 in radians. So a times b is equal to pi over 2. Okay, so I've got like one equation, you could say, right? Because, no, not pi over 2, sorry. Pi over 3. Pi over 6. My bad. Inverse sine of a half is 30 degrees, which is pi over 6 radians. Pi over 6, sorry about that. Okay, good. And another point I could choose, for example, is this point over here. Okay, I can choose this point over here, which is, I could even choose these points, by the way, as well, if I wanted to. That would also work. Okay, but let me just choose this point over here, which is 2/3 pi for x and 1 for y. So I can say 1 is equal to the sine of, and I'm going to have a times 2/3 pi plus b. Okay, so what I can do now is I can say inverse sine of this. So I have 2/3, I'll have a times 2/3 pi plus b is equal to, now inverse sine of 1 is pi over 2. Okay, so I'll end up with this giving me 2 over 3 times a pi plus ab equals pi over 2. Now I know already, I can use the space up here, I know that ab equals pi over 6. Okay, so if I take this up here, continue on up here, I have 2/3 a pi plus, now ab is equal to pi over 6, so I can put plus pi over 6 is equal to, and we know that that's equal to pi over 2, so 90 degrees. So if I rearrange this, I have 2/3 a pi equals pi over 2 minus pi over 6, which is, that's going to be 3 pi over 6 minus pi over 6, which is 2 pi over 6, which is pi over 3. So I have 2/3 a times pi equals pi over 3. Well, the pi's will cancel out, the 3's will cancel out. I'll be left with 2a equals 1. So a equals a half, which is exactly what we found. And if we know a equals a half, we know ab equals pi over 6. So b equals pi over 6 divided by a. So it's pi over 6 divided by a half, which is pi over 6 times 2, which is 2 pi over 6, which is pi over 3. So b is pi over 3, and a is a half, exactly what we found earlier. A bit more of a palaver here. We could have chosen other points, I guess, as well. We could have chosen x is minus a third and y is 0, and the same for 5 over 3 and 0. Maybe we could have done that also. It could have worked, but I just chose these 2 points here, and I found a is a half and b is pi over 3, exactly as we found in this question. Okay, so as I mentioned with transformations, you can answer this question very quickly. You don't really have to show any steps. You can just have to understand we're dealing with BIDMAS, and we're going to first deal with the translation, with the multiplication, because we do the opposite of BIDMAS. So it's going to be, you can see that it's the multiplication is to do with the stretching, and it's stretched by a factor of 2. So you're going to have a half as your stretch factor. So half has to be a, and then it's translated pi over 3 units to the left. So it's going to be pi over 3 as your b. Very easy. You don't have to spend a lot of time on it. I spent a lot of time on it because I want to explain the basics behind it. Now for part B, it says another curve with equation y equals f of x has a single stationary point at the point PQ. Okay, you don't know what the equation of the curve is at all. We just know that this is transformed to a curve with this equation. Okay, so now we have to bring to mind some of those things that I mentioned. All right, so you're starting off with the point PQ. And PQ is transformed to something that we have to find. All right, now in this case, the easier one to deal with is Q. You know that Q is going to be transformed in such a way that you have to multiply it by -3. It's multiplied by -3. All right, so it's going to be -3q. That's pretty simple. So that part's going to be -3q. Okay, -3q. There's only transformation outside the function is multiplication. So it's multiplied by -3. So it's a vertical stretch of -3. So it's reflected and also stretched by a factor of 3. So that's what we can say is the coordinates of the point Q after the transformation. As for this affects what's inside the function. All right, now there's 2 ways we can deal with this. One is in the same way that I mentioned. We can say the opposite of BIDMAS. So because we got a multiplication and a bracket, we'll deal with the multiplication first. So I can say that the P, first of all, okay, the first thing that has to happen to the P is going to be multiplied by 4. So it's going to be P times 4, which is equal to 4P. And then what's happened is you have a stretch, a translation of 8 units to the left. So the second thing is going to be you end up with the 4p, and you're going to take away 8 from it. Why? Because it's a translation of that number of units to the left. So you end up with your x coordinate is going to become 4p minus 8. Okay, so we do the opposite of BIDMAS. Alternatively, what we could have done is we could have said that this is the same as -3 times f of, and we can multiply that out. This is a quarter x plus 2. Okay, a quarter x plus 2. And for this, what we can say is, all right, the x coordinate of p, first we have to do with the opposite of BIDMAS. So first we have to multiply it by, a quarter x plus 2. A quarter x plus 2. So first of all, we have to multiply it by, first we have to do the opposite, but first we have to take away 2 from it. So we're going to do, first we're going to get p minus 2. So the first thing is we're going to take away 2 from it because we do the opposite of BIDMAS. We do addition first. Plus 2 inside the function becomes take away 2. So you have p minus 2 first. And second, we have to deal with the multiplication. So whatever the coordinate becomes, we have to multiply it by the reciprocal of a quarter, which is 4. So you end up with 4 times p minus 2, which, as you see, gives us the same thing. Okay, so whichever way you think about it, whether you think about it like this, where you're thinking about, okay, opposite of BIDMAS, multiplication, and then bracket, or you think of it as expanding this, the addition and then multiplication, you end up with the same coordinate 4p minus 8. Okay, now this part of the question, part A, most people got it correct. But part B, a lot of people messed up with this particular question because of the order of operations for what's outside the function. The y coordinate was mostly correct for most of them, but the x coordinate was a bit messed up. So this is two ways we can think about it. Okay, it's important to understand transformations inside the function, outside the function, in the same order as BIDMAS, opposite order of BIDMAS. Very, very important for us to understand that. So there we have the answer to part B of question number 8. Other questions from this particular paper can be found in the playlist that will appear in this section over here at the end of the video. Other questions from the topic of trig graphs, I'll put over here, and transformations of graphs, I'll put over there. Okay, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.